So let's start with this about the CFA. Let me just recollect once again what the CFA is and how we have done. So I was just writing answer to your queries. I will take it in the next session. Let's start with the R, and I'm starting with the CFA. Look for the thing. Number one, you got a basic idea about what the model is. In my file, there is a satisfaction, loyalty, quality, and the behavioral intention. Some got 5 statements, some got 3 statements, 4 statements, 6 statements, something like that. Now to start with, I'm starting with the CFA. The first step is always import the file. One, two people said that you give only the CSV file, not the SPSS file. Yes, the reason being, when you work with the SPSS file, particularly for the CFA, when you want to get the score, that will not work. That says it's some labeled are there, because you remember in the SPSS we give the value label. So that is somewhere some problem is there. So for that I give you the CSV file that works fantastically. So don't worry about it. It will work with all. The second thing, I will request not to type anything in the chat box now, please. It distracts. First thing is import. So let's import. Let me just clean this entire slate. Clean. Okay, nothing is there. Now let's start from the start. The first thing is import. Import from readr. Readr means CSV file. So where it will search, there is a default folder. How to make the default folder for every session? Control Shift H, or you can go to the session, set working directory and choose directory. You can choose it from there. Then name of the file is a demo. I'm working on this time. I am working on the other file. The demo.csv and demo.sav file got slight change in the data also. So if you work with the both, you won't get the same results. It's the same. Okay. So let's start from here. I import. The initial 3 steps are IVA. I have imported, and now see, if you just look at once again, in itself, when I open this particular window, there is something called view dataset automatically there in that. That's why it imports and it views. And look for the view V is capital. This is one where V is capital. Well, otherwise, we write all the commands, all the functions in the small cases. And next up is attach. So let me attach it. So I will go to the CFA, and there it says attach demo. Hope it's visible to you now better. I minimize it because there is no use. So this is my input and this comes my output. Cleaning the console, Control L. So attach demo. The first 3 steps are done. It says masking. Yeah, no worries about masking. First 3 steps are IVA, import, view, attach. You can import, attach and view, or view, attach. Import is first, then next thing. The 3 steps are that you need to do, other than setting your working directory for that session. Then I'm not working on the entire file. I'm not working on the age, profession, income, gender, etc. So I'm starting from this. So that's why capital bracket means the 2 things are there for the extraction part. One is capital bracket, second is a dollar. Dollar means from the heap of from the plethora of output, give me relevant output. That is the dollar symbol. And what is the bracket? From the input data, I want some selected portion, not the entire portion. I want some selected portion. So if you leave it blank, if you write this way or you write this way, it's one and the same thing. There is no difference in the same. So first it says rows. If you don't specify, it means all the rows, and column from 10 to 30. Why not first 9? Because they are age, income, gender. They are not on the scale. So in EFA and CFA, we take only questions which are asked on the scale. Any scale, 4 point, 5 point, 6 point, 10 point, every will do, but not the ranking question, not the binary questions, not the multiple choice question, etc. Z we have done. Head. When you write head, it means first show me the first 6 lines of my data set. It's always good. You will find number of videos. They say once you attach a file, always see whether it's the correct or not. So it will say it consists of first 6 rows. It will show quality 4 columns, and it said 17 more columns are there. The names of the columns are like this, like behavioral intention 6, quality 1, 2. Now I'm sure that there is nothing like. Let me make certain mistake here so that you will understand. Now when I say give my head me the demo, it says English and Hindi are also there. Look at it, English, Hindi, these are the marks. These are not the part of skill. So I will say, okay, I made a mistake. It is 10. Head. So head says, show me part of my data, whether I have attached the corrected data or not. In case if there is any missing, the other part for the head is, you can make a guess, it's a tail. Show me the last 6 rows of my data set. So it says these are the last 6. So there are 17 more variables, but this is the data in the last of the 6 rows. So that's people say that you should once check so that there is no mistake. Descriptive, if we may skip it, we don't require it. Now coming to the next part, I'm cleaning the console. Shortcut for cleaning the console is Control L. Why I need to clean it again and again? Because I have done a zoom a lot so that you can see it. Otherwise, you know, because of zoom, only 5-6 lines are appearing. Otherwise, in the normal data is there. You need not to clean it that often. Make a diagram. How to make a diagram? This is important. How to make a diagram? We write equal to tilde. So when we write equal to tilde, this is my, that what we infer, this is equivalent to the circle, and these are quality 1, quality 2, quality 3. These are the statements. Whatever statements we want, we work. Now, can you make a guess out of it if I'll write something? If I'll write loyalty is, it's not like this much space is required. It's just, you know, OCD. So if you write like this, quality plus satisfaction, can you make a guess what it becomes? So I said satisfaction is made up of loyalty, behavioral intention, and then loyalty, instead of this, I will skip from it. I don't take this. Oh, my mistake. I write a quality is equal to this plus this. What it becomes? Now it becomes loyalty is made up of this. This is second order. Can you see? So simple. This becomes the second order, because what is loyalty? Loyalty is made up of quality and satisfaction. So this becomes as the second order. So let me go back. I don't want to. So 4 constructs I have defined. And what is this? This is double. What is a double tilde? Double tilde means correlation. So see this once again. So latent variable equal to tilde, that is used in CFA. Composites, we will say less than tilde, that becomes composite. Regression, tilde. So later on, after doing measurement model, when I will go for the structural model, I will use single tilde. And double tilde is correlation. And if you want intercept, then intercept is tilde 1 will give you intercept. We don't require it now. Maybe we require it some other places. So let's go here. Quality leads to quality related to satisfaction, quality related to behavioral intention, to loyalty, all possible I have written. And please see, if you forget about it, can you see the green color? Now the green color is gone. Why it's gone? It becomes, it's a regular thing. For the green color, you must put all in the tilde one. Put it in tilde. It means now this entire, not the tilde, sorry, my mistake. It's called apostrophe. So put all into a pair of apostrophe. So what it means, now this entire will be taken as one. It's just like, you know, putting a sort of bracket. But here the syntax is put everything into this one. So this is a very common mistake with the beginners. They look at the color. Color is this. And when the color will come, only, otherwise it's a text file. When you save it with the extension of .R, it's a simple routine text file, notepad file. But only when you save it with the extension of .R, and when you open it in RStudio, the text editor will recognize this is a calling function. This is a green color is something particular way. When you write a hash symbol, hash means, hey R, don't read this line. So that is in languages part, it's called comments. So hash, when you write hash, R says, okay, I won't read it. So I have defined my model. Let's run it, run the model. Now, these two are the parts. Just like in the Amos, what are the two things? In the Amos, number one, you make a diagram. You make a diagram and run, it won't run because it will say the file is not attached. If you attach the file and have not made the diagram, you run, it will, Amos will say, where is the diagram? So two things it requires. It requires a diagram and a SPSS file. We need not to open the file, just file should be there. It means it requires a data, it requires a diagram. The same, the two things are here. X means it is my equivalent to a diagram, and give data is equal to Z. So that is my data. Where, why Z, why not demo? Because the demo contains those 8, 9 multiple choice questions, etc. Z contains only the Likert scale statements. So when you run CFA, it will run and the output will go into XX. Why I'm doing sick? Why I'm not directly doing like this CFA? Yeah, I can do this also, but XS will contain a lot and lot of things. I can say I want this output, this output, this output. That's why I require XX. So let's run. Now I say like summary. I'm making it little large. So only two things, summary XX. This is a very, very common thing. So whenever you go through any workshop on RStudio, this is the first thing they will say, do something and find its summary. You know, it's always do analysis of variance, do correlation, regression, always find summary. Go for the table, 2 by 2 table and do the summary. The chi-square value will come. I have explained all this. Some of you asked that when can I take a workshop on R? The video of the previous weekend workshop are available on YouTube. So you can just go through there. It's a 6 session of 1.5 hours each. I have discussed all these basics there. You can quickly go through. So summary XX, let me make this size little bit more so that you can see it comfortably. I'm in row number 31, control enter. So this entire values are here. So let me make it little small. However, zoom I will do, it will always give something in the next line. Hopefully these are in the one. So what are the values? It starts with the estimator is the maximum likelihood. Free parameters are 48. In MOS also there is something called the parameter. There is something like the estimators. One scholar has asked the question from yesterday. She is asking the question about variance covariance matrix. Variance covariance matrix is actually input to the MOS, and on the basis of it, it calculates the various things. So that particular thing is called degree of freedom. I have explained in one video in much detail about what is degree of freedom, how it is computed, how MOS works, what are the things it take into consideration, what is exogenous, endogenous variables, free parameters, etc. I have explained in detail. So please see that video that's available in the MOS playlist. Free parameters are 48. I have given the how to calculate what is meant by free parameters. It's, you know, it's not directly required, but it's always good if you know about these things. Test statistics 410, degree of freedom is 183. Can you see roughly it's a 2 point something is coming. So it means our model will be good. Latent quality, look at the last one, std.all. Okay, let me check one thing. What if I don't write the std, only take the summary, will it give me these values or not? Let's check it out. So remove this and summary. So it has not given me those values. It has given me only estimate, standard error, p-value. Now somebody asks, what is the meant by the p-value? Whenever you see p-value, always look for 5 things come together. This is the part of from the bivariate analysis, hypothesis testing. P-value indicates there is a test going on. The meaning of the test means you are comparing whether any 2 or more things are same or not. Looking at the p-value, if it is less than 0.05, whatever 2 things you are comparing, they are not the same. Okay, so this is any of the test is applicable. T-test, Z-test, F-test, chi-square test, any of the test. Test means difference in statistics. So what is the null hypothesis here? Null hypothesis is this 0.885 is equal to 0. SSE is such a small value, it is 0. The statistics tells no, it's not 0. It's a robust value. So it is quality is able to predict this. Okay. So this is the first parameter I said that the p-value should be less than 0.05. But it is not giving me that standardized value. For that, I have to give the second argument. The second argument in the summary is std is equal to t. Now see, R works a lot on abbreviations. Actually, in the books, you will find true. You must write standardize is equal to 2. But it works so much on the abbreviation. It's just like, you know, our own WhatsApp in RStudio. So we write std, it understand, okay, you are talking about standardize, and I write capital T, it means true. Capital true T or true means please show me the standardized values also. By default, it's not showing me. So now hopefully it will show me. So yes, it show me the standardized value, std all. So look at this value 854, etc. What will be the purpose of this? These will be used for AVE calculation. What is AVE? Average variance explained. So what is this value actually? This is the R between quality, that's remember circle, that's intangible, that's a sort of inferred one, and quality one. Quality one is the box, the measured one. So its R is 0.85. So if you do its square, it will be R square. square for all the 6 and take its average, that will be called as AVE. Now for that, we have this file available with us. We will put the values here and it will calculate AVE and CR. Somebody asked what is meant by the error. So please look for this formula of reliability. It says sum of the standardized loading. For example, I write 0.85. So what is this value? It's simply the square of this 0.85. It comes this. So 1 minus this value will be the error term. What is the purpose of error term? The error term is used here in the calculation of reliability. See, it says sum of loading. So 0.85 whole square divided by 0.85 whole square and plus sum of indicator measurement error. Error in statistics is called as residual. It's not any mistake. You know, human beings, we take error means mistake. Here it means residual. What is residual? Which is not explained. This much portion is explained and 27 is not explained. So that is used in the formula, in the reliability. That's I have given, but there is no interpretation. It's used in this calculation. That's why I have given it there. Formula also I have given. So now quality you can find out from here AVE. And the second thing is what is MSV? Look for the quality out of the 3, which is the largest, 0.71. Its square will be 0.5. So AVE of quality must be greater than, this term is called MSV, maximum shared variance. Likewise, when you look for the satisfaction, you want to look only the 2 value. Don't forget to look this value also. Satisfaction is connected with 3. So satisfaction with quality comes here, 0.45, 0.3 and 0.7. Square of 0.7 will be the third thing, that is MSV. For the loyalty, one is loyalty here. I can see here 0.713. Second loyalty is 755. Third is 557. So square of 0.755 will be the MSV for the loyalty. What is the formula? CR should be greater than 0.7. How to find out the CR? Put all these values in the Excel file. It will give you CR. This should be greater than 0.7. AVE should be greater than 0.5 and CR should be greater than AVE. 3 things, tick, tick, tick. It means convergent validity holds true. Take the AVE, compare it with the MSV. If this is greater than MSV, it means discriminant validity hold true. Now, what if they are not good? You know, this is the question main. If in this case, let's look at this satisfaction 1. Should I compute it? Because one value is very high, other is very small, 0.475. Let me compute that. Second is 0.929. Third is 776. And fourth is 656. AVE is greater. Let's say this beta value is 0.7 in case. Can you see AVE value is now 0.4. It is less than 0.5. Now what to do in such case? Remember, this is a reflective construct. The same thing asked again and again. There is one statement which somehow people were not able to understand. It's not beta is coming not good. Delete that statement. With the lowest beta, delete the statement, and you can comfortably do so because you are using the reflective. The same thing measured again and again. Doesn't matter with the rest of the 3 also it will be the same. One, somehow people couldn't connect. Maybe some word was such, context was such, people were not able to check for it. That's why you can remove. When you remove any of these statement with the lowest beta, that's perfect permissible because it's a reflective one and you can go ahead with that. How to improve the discriminant validity? So in case of the discriminant validity, why it is violated? The answer of the discriminant validity you will not find here. The answer will you find in the EFA. See, so CFA automatically contains EFA. Go run EFA, somewhere you will find a cross loading. 100% you will find a cross loading. Check that cross loading and remove that cross loading. Discriminant validity will improve. Okay, so for the discriminant validity, 2 are the methods. If the discriminant validity is violated between number of independent variables, please see, can it be a case of second order? Does it make sense if you all connect together? Then it becomes second order. If it is between like independent and mediator or mediator and dependent, where no point of clubbing those, then remove the cross loading. Okay, if it is the reflective, your things will be good. If it is formative, then God help you. Variance we don't require. Then we require something like model fit, etc. The command is fit measures. And now see, earlier I made a model. I put a model and a data. And now everywhere I am using this XX. What is XX? XX contains the output of CFA. So that's why I have taken the output in this and then put here. This method is called iterative process. Take output, put it in the next. Take output, put into the next. Take output, put into the next. We do quite often with this. Fit measures. So these are all the fit measures possible. Standardized solution. So this is the complete solution is visible here, along with all the things like estimated standard error, Z value, then lower value, upper value, confidence interval. Some paper, some reviewer ask for these things. So this is also available. Next is the modification indices. So that is also available. You must know the theory behind it, which things we can connect. Only those things we can connect which belong to the same construct. The statements, error terms of the statements belonging to the same construct may be correlated. I have explained in the video of modification indices what is the theory behind it, and you should not give so much. If you say I have used so much of the modification indices, it's an indirect way of saying my review of literature was very poor and I have not worked correctly. So it's just a sort of a what you call first aid kit. So it's not a substitute of your review of literature. So you say there is indirectly you are saying there is something unseen in my data, which that's why the error terms are connected. So loyalty and behavioral intention cannot be connected. Doesn't make sense. Like loyalty with loyalty, yeah, it may be there. Behavioral intention with behavioral intention, it may be connected. Professor Gaskin has written a lot about it. Please read his webpage. We can use the lev predict. Now problem with the lev predict is if you have imported a SAV file, SPSS file, it may not work. It will say haven't labeled or something. But in case of this file, it will work. Then take out the quality. I have taken. Now I have taken the score out. If I'll write here QUA quality, just see this will give me all 100 values. Remember, these are the Z values. These are the Z values. So if I want to run the regression here, structural model, I'm writing summary LM for the linear model. So BE. So I need not to remember complete. Its name is BEH. I have given. Okay. Depends on. See it now single lateral means it's a regression. It depends on quality. No. Its name was QUAL quality plus satis plus loyal. Okay, this becomes a multiple regression. This is the structural part. That's simple. So let's run it. This value, remember what is the 3 star? 3 star means the value, the p value is less than 0.01. It's an extremely small value. What is a single star? Single star means it's less than 0.05, less than 0.05. And dot means single. Can you see a dot is there? A dot means it's less than 10%, but more than 5%. I think this is given here. Codes are given here. If you just read it here, the 3 star means very almost 0, 2 star means up to 0.01, 1 star means 0.5, and so on. These are codes are given. So it means when I predict behavioral intention, satisfaction has at 5% if I work, satisfaction has no role in predicting behavioral intention. And quality got a very good relation, and satisfaction got a very good relation. Very good means okay, it's acceptable, less than 0.5. R square comes out 55%, adjusted comes 53%, and so on. F statistics is good. So this is what we do later on. From here, it will emerge the mediation moderation that we'll discuss in some next workshop. Not today. Not hierarchical, not actually hierarchical, etc. I have discussed in the previous workshop. The videos are available. Last weekend workshop, you can see it there. Hierarchical and others, I think stepwise regression, I have explained in the last week. Samplot, if you want to see the diagram, you can make this diagram. I have written the codes for the mediation and the moderation. I will not discuss. The same thing I have explained in some of my video of RStudio. You can see it from there. So this was the CFA part. Now let me quickly go through the Smart PLS part. But for the Smart PLS part, let me first show you Gaston Sanchez. Is one of the wonderful person. Gaston Sanchez, he's the Gaston Sanchez. So he's working as faculty member in the University of California, Berkeley. He teaches statistics. He got a site also, gastonsanchez.com. And just like Andy Field, I'm a die-hard fan of Dr. Gaston Sanchez. He's written a number of books where majority of them are actually free of cost. This is currently work in progress. All models are wrong. Matrix algebra, PCA for data science, introduction to computing, handling strings. Well, I loved this book. When I started text analytics, I first went through this book. This is freely available. A new book download version is available, and it teaches right from the basics of what exactly text, how to work with it, what are the function, base function, packages it gives you. Pack your R code if you want to make R code, booklet, PLS path modeling. One, I will refer those who are interested in statistics, like Sandeep, like Yasha. You must read this saga of PLS, the entire story of, who did what, then he went there. It's a history book, nothing to do with the statistics. It's a history book. So how the PLS was developed, the two world, father and the son world, and their story. PLS path modeling, this is the book which talks about the PLS-PM package. Okay. So, and then he talks so much things he has shared. He's contributed a lot to various things like path mocks. PLS depot is another one. These are the so many packages he's contributing. This is just wonderful. So now let's talk of this package. Now this package somehow is not available on CRAN. So how will you find this package, PLS-PM? So I told you, you please write here as PLS-PM and GitHub, 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 PLS-PM, GitHub. So the first one come, Gaston Sanchez PLS-PM. Here, this Gaston Sanchez has given two commands. These are the two commands. Simply copy it and run once, and you will get this package. So this is an alternative repository. I told you it's a GitHub. Number of, it's not something like it's an inferior product, not something like. So much wonderful packages are available here on GitHub. CRAN has its own, some methodology, what to put, how to put, maybe people reported some bugs, etc. But this works fantastic. So you need to simply copy, paste, and press enter. You will get the PLS-PM package. So let me open the PLS-PM, a simple one. This is the package. Now, before starting this package, it's a simply, again, 3-line package. Require PLS-PM. Yeah, it's available with me. Attach demo. Do I have this? Attach demo. Yeah, I have that. Okay. View not required. That's already I have viewed. Now it comes, you need to understand Professor Sanchez's way of working. He says, you remember in the CFA, we wrote a code. Professor Sanchez said, no, give it into this format. And this is again a very simple format for very, very complex things. So this is a third way of making the diagram. One making of diagram, you remember this by circle and arrows in Amos. The second was we used to write like qual equal to tilde, and then I will write Q1 plus Q2 plus Q3, Q4. That is which was the package? Lavan. This was the package we were writing this way. And now we are explaining the part in 0 and the 1. So you need to read it as like in this one. How will read? Quality has an effect on loyalty. This is what his arrow means. Satisfaction has an effect on loyalty. That's it. 3 are the constructs, and all the 3 constructs constitute multiple regression. How will write? Read this as effect of this on this. So if I'll add one more column, please read this as on. Please read it as on. On means we will be effect of this, effect of quality. Now just check it out and tell me, quality has an effect on loyalty? Yes. Quality has an effect of quality? No. 0 means no. Quality on satisfaction? No. Quality loyalty? Yes. 0 means no, and 1 means yes. Satisfaction on quality? No. Satisfaction on satisfaction? No. Satisfaction on loyalty? Yes. Loyalty on anything? No, no, no. Now this is the way I need to code. So it's a so funny thing. How will I write the code? See, I write quality is equal to C. That's a sort of a concatenation we need to express. When you express 5, 6 things, we put a C. C means in this order. Okay, the meaning of the C is in this order. So it's 0, 0, 0. How you know it's 0? Look at horizontal, read it horizontally. So quality 0, 0, 0. Satisfaction 0, 0, 0. So satisfaction, I have written it wrong. It's 0, 0, 0. loyalty, it's 110, 110. So this constitutes my diagram. This is my diagram is done. So you will just love it for the very, very complex models, you know, the mediation, moderation, multiple serial mediation. It will be just fun writing 0 and the 1, and these diagrams are done. Now, I want all the three taken together. Taken together is called binding. Binding how? Column wise or row wise? Row wise I want. So there is a package, simply function rbind. Don't remember it. The script is available with you. Now this is X. Okay, this you may not require like inner plot X. See the diagram. Quality leads to loyalty, satisfaction loop. Is this diagram okay? This is what you are looking for, this diagram. Quality leads to loyalty, satisfaction leads to loyalty. Okay. Now, shall I try to make the color something? Will it work? I'm not sure. No, it's not allowed. Okay, sorry. So this particular is I can skip. This is not mandatory part. X is okay, inner plot. Now look at the PLSPM. It got only 4 arguments. 4 arguments which are necessary. First argument is your file. So I have the file demo. Okay. But I'm not taking out the removing the first 9. Remember in the last time I was doing? No. Professor Gaston Sanchez said, no, don't do that. Actually, show me, tell me the complete file. Tell me that your diagram, this diagram is in X. Then there is a third thing, out. Out means now you tell me from your data file, which particular, like remember you have given quality. Quality is from which column to which column. So look, in the CFA, we were saying all columns except these 9 columns. But here, Professor Sanchez says, no, you tell me this quality is available in which particular order. So I said, I made a list here that 10 to 15 is the quality. Shall we cross check it? Check it here. 1, 2, 3, 4, 5, 6. Qualification is 6. 7, 8, 9. Then quality 1 starts. It starts 10, 11, 12, 13, 14, 15. From 16, satisfaction will start. So I have written 10 to 15 in the same order. First I have written quality, so 10 to 15. Then satisfaction, 16 to 19. 4 are the statement for satisfaction. Loyalty, 20 to 24. That's it, 3. If you write here as by mistake, you write 25. So it will say there seems to be some mistake or etc. Or maybe for these loyalty, you got this much statements. So do you understand the basic difference between CFA and it? In the CFA, that said all the files, all the columns, except the columns you don't want to use. Professor Sanchez says, no, whatever the way you have defined, write what is their sequence in the file. Since you have not written 1 to 9, they won't be considered. This is also taken. And this is mode. What is meant by mode? Remember, CFA, which works on MLE method, work only with the reflective. The one of the reason we study for this PLS is it can handle the formative also. Now this is also PLS, na? So there reflective is called mode A and formative is called mode B. Now by default it will be considered. There is no necessity to write, but if in case you say no, my satisfaction is formative, you know what you need to do? All you need to do is make it as capital B, and that will be considered formative. As simple as that. You won't believe it. So it's so simple. If it's a reflective, actually will happen. I told you number of times, when I say reflective, always look the term loading. Formative, wait. In the formative, study the wait. In the reflective, look for the loading. Now, let's come. PLSPM. First is demo. Demo is the name of the file. X is my diagram. This one is X, and I have defined these 3. So together it becomes my diagram. What is out? Out means the relative position of all the statements in my file. What is mode? Mode is reflective or formative. Even if I'll skip, all will be taken A. Then what is the next? I said scheme is equal to path. So I want that path analysis. If somebody has worked on Smart PLS, you want to work for factor or centroid or path. Do you remember that? If you have attended any workshop, so it is that. So that means if you want factor, if you want centroid, you can change that. Otherwise, let it keep as this. Do you require bootstrapping? In Smart PLS, you need to do it twice. One is PLS, which PLS algorithm, which gives it directly, and then there is a bootstrapping for P value. In one go, we will say boot dot value. I require bootstrapping. BR, how much sample? I am taking a sample 500 so that it runs fast. You should take 5,000 minimum. Run the output will go to the XX, and then I will take out the output. Everything will come. That's it. You know, this much things of the Smart PLS we can do only in this much go. Look at the 4 points once again. The first point is my file, entire file, nothing taken out of this or that, entire file. Second, my diagram. My diagram is very fun here because I will make this sort of thing, whatever complex diagram. Now next we are going to work on this diagram. Okay, so just see how many arrows, which arrow is going where, etc. So in the form of this Excel file, not Excel, you can make it in copy and pen. It's a simply one means yes. So it means 1 and 1, only 2 arrows are there. Yes, only 2 arrows are there in my diagram. 1 means yes, arrow is there. It will read from top to bottom. Effect of quality on loyalty. There is a relation. Yes. If I will say there is a one more arrow from quality to satisfaction. What can you make a change? What you will change? So we will just make a 1 here, and it becomes a case of mediation. Isn't it funny? Simply three arrows, so there will be 3 1. As the moment I got 2 arrow, so it's 2 1, right? So please remember this. You need to know that I have given this Excel file also to you. Its name is model specification. So then this is my diagram. Then my relative position of the statement in the file, mode, reflective, formative. By default, all are this. So let's run it. XX. Default mode is used. It said I don't worry about that. Okay, now take the summary. It will give you everything. That's the fun here. So let's remove it and take out the summary. Okay, everything is given. Now let's start from the top. Isn't it funny? And people have given it free of cost. Can you believe it? Just hats off to Professor Sanchez. Number of cases are 100. Latent variable are 3. Manifest variable means how many total number of statements are 5. We worked on the standardized data. Non-metric PLS, no. Weighing scheme is path. It could have been factor or centroid. Tolerance criteria 10⁻⁻⁶. That's the same in the Smart PLS also. Maximum iteration 400, convergence 4, bootstrapping done with a sample of 500. Now it says quality is an exogenous variable. What is exogenous? Arrow is going out. X means out. Yes, quality is exogenous, arrow is going out. Loyalty arrow is coming inside, so it becomes an endogenous. Loyalty is endogenous. Loyalty contains 5 statements. Satisfaction contains 4 statements. Quality contains 5, and all the 3 are reflective. Okay, go ahead. Cronbach alpha, more than 0.7 in all the 3 cases. Wonderful. Now it says when the people report Smart PLS, they often report the Dijkstra's rho. So that is also greater than 0.7 is good. So all are good. There is one more criteria. Eigenvalue of the first must be greater than eigenvalue of the second. So in all the 3 cases, it is true. So this is not available in the Smart PLS or any other software. It's their own. And remember, for this complete, the book is given by Professor Sanchez. You can read, you can download from his website, and all the details are given free of cost. So now it comes to quality. Which one I should read? Should I read weight or loading? How to see? Check whether it's a reflective or formative. It's A. A means it's a reflective. So in the reflective, always look the loading. Okay, look at the loading. So what I will do next? I will take all the loadings. I will go to my Excel file, put the values here. I will get AVEC here. Rest of the concept are the same. Therefore, CFA, nothing with the to do with the algorithm. That's the same. Find out the, hope you will be able to find out AVE for loyalty, for satisfaction, for quality, all the 3. Cross-loading. It says, look at it. Quality is there in quality also, satisfaction. The rule is, if you are naming it as quality, so it should be highest in its own way and lowest in the others. That's okay. That I think in all them are okay. Satisfaction is highest loaded in the satisfaction, others it's low, loyalty in highest this. So this will give you idea of cross loading. If there is something which is going like, I can see this quality 4, this is 0.7, but it is 0.61 in loyalty. This may create a problem. Remember satisfaction 2, I remember very high in satisfaction, but at the same time 0.656. It's may put a threat to the discriminant validity later on. And likewise here, is there anything? Yeah, loyalty 4. Loyalty 4 is highest in loyalty, but again in the quality it is a little bit high. So this one comes as the cross-loading. Next it says inner model. Remember what is the inner model? Inner model is the structural relation between the constructs. So it's basically loyalty depends on, how come loyalty? DV is always written on the top. See here, it's a loyalty depends on quality and satisfaction. So it says quality, p-value is very, very small. There is a significant effect of quality. There is a significant of satisfaction. Both are good. It's a case of multiple regression. Both are good enough. What are the correlation between latent variable? What is the latent variable? Remember, factor is again called a latent variable. I told you the 4 names: factor, construct, dimension, latent variable. So many people call with that different. So can you make a guess from here? When Professor Sanchez is calling it a latent variable, it means he is from the statistics department. So people of statistics call it as a latent variable. Quality with quality 1, with satisfaction, this is the correlation, this is correlation, etc. You can flow on that. If you don't want to compute, it has done AVE part for you. It has computed AVE. You just report it from here. It works on the goodness of fit also. I think Smart PLS also works on the goodness of it, 0.57. Okay. Total effect. Now this comes a part of the regression. Quality leads to satisfaction. No, there was no such relation. Quality to satisfaction, no such relation is there. That's why 0, 0. Quality leads to loyalty. There is no indirect effects, so the direct and the total becomes the same. Indirect is 0, quality leads to loyalty the same. Now we come for the bootstrapping. Bootstrapping, there are the, in the last workshop I told, there are the 3 ways of checking the hypothesis. What are the 3 ways? The first way is calculated value less than table value, null hypothesis accepted. Second, p-value greater than 0.05, null accepted. Third, if the limits, the percentage limits you are checking, if their sign differ, the null hypothesis accepted. If the both are same sign, both negative, both positive, it means null rejected. So what is the null hypothesis? This value is equal to 0. Weight, let's check that. All weights are significant. This is not 0. Look at this only. See, it's so fast, super fast. Don't look at the value, just look at the what you are looking at. Look at the sign. This column and this last 2 column. If any change in sign is there, it means that is 0. So here none of these are 0. They are good in terms of weight. When we will report this weight, if we have any of the construct as formative, then this. Remember, Dr. Sandeep told you 5 things to be reported. First, look for the multicollinearity. Second, look for the size. This is the size, 0.19, 0.21. Third, he said, look at the significance. This is the significance. Both values are same, so it is not 0. That is significant. Remember? And then he said, look at the redundancy. We'll talk about that. So weights are okay, though it's not required because all the 3 are reflective. We don't require, but yeah, we require loading. Yeah, come to loading. Loading are also correct. All great. There is only one possibility when the lower value is negative, upper is positive. That is the only possibility when this will be 0. If both are negative, both are positive, this will never be 0. These are the path. Remember earlier it has given only the value. Look at the top here. It has given 0.47 this. Now it has given me the p-value also. The p-value 0.47, it is significant? Yes, significant. But there is no p-value, not required. Look at this value, third method. That's why in the last workshop I told you there is 3 methods. Look at that. Most of the now today's softwares, they don't give you p-value. They give you the limits. In the limits, if 0 don't fall between the limits, or in simple terms, if both are positive or both are negative, then whatever you are looking, this is not 0. If lower is negative, upper is positive, this is as good as 0. So both are significant. What is R square? 56. Is it 0? No. What is the total effect? These are the total effect. So just how do you like it? Isn't it just magic? 3-4 things we defined. We require PLSPM. Second thing, let me clear it. Attach demo, that you know, attach, we have to do IVA, import, view, attach. This is my diagram. This is making my diagram. So diagram we'll make in some copy and pen or maybe Excel. Diagram is in terms of 1 and 0. Then show the list. This name, you can write anything. It's, if I, instead of out, I write Neeraj, it will work. But the only thing is write here as Neeraj. It's whatever the name you define, the same name should be here, any name. Okay. So what is this out? This is a list containing the relative position of these indicators of this particular construct. Again, if you write here as set or seti or satisfaction or something, absolutely no problem. Whatever name you write, please remember that name. Now this is the command. How many arguments are there? 3-4 arguments are mandatory. First one is, one more thing. See, it's first two. First is demo always. But if you, instead of mode here, if you write here, mode first out later, no problem. It will work. Okay. So first is the file. Second is diagram. Third one is what is the relative position. Fourth one is whether it's a reflective or formative. Now, shall I make it as formative? These two are formative. Now, again, I have just put it here, but otherwise you must have a theory behind it. Why formative, the reasoning, rational behind it, review of literature, you must write that part. But here, let me show you. Will it work? Because of bootstrapping, 500 samples, it's calculating that bootstrapping. So whatever you will define as B formative, what will happen? Reliability will not be calculated. AVE will not be calculated. Only weight will be calculated for that. In the meanwhile, it's working. Let's see what are the other things. Now you can do rest of the things, like you want to plot it on graph. You can plot XX. Remember what is XX? Output comes in the XX. Two sort of plots are available. Then if you want something particular data you want to see standardized context, you want to see the goodness of it, measurement model separately, inner model, outer model, convergent validity, R square. If you want to see any particular thing, you can write it separately. See, I show you once, like I run it, XX is available. Now XX dollar, and it says I got this much things. So when you simply write XX, it will show you all. If you want, no, I want only one, this inner summary, it will show you that. So first let's see summary XX and what differences it will create. First, let me clean this. Control L for clearing the console. Summary. Okay. Let's see what it is telling. The same, now it says it's exogenous, but the mode is B and the mode is B. What is the meant by mode B? Where is the Cronbach alpha for satisfaction and loyalty? Why it's 0? Because for the formative, we never calculate. Remember, alpha means consistency. When it is formative, how can there be consistency? There are totally different things. So no consistency, no alpha will be calculated in case of mode B. Isn't it so intelligent? Wonderful. Just write a B and it's become so wonderful. Now quality, we will read out this, but remember satisfaction. Now 8.01, etc. These things I will read out. 0.08, 0.00, and it seems pathetic. And loyalty also, because my data is actually reflective. When I try to make it as the formative, it sort of resentment is show 0.09, 0.00, so low are there. Yes. Cross-loading is the same thing. Inner model, the same thing, it's coming. Correlation, the same thing. Look at it. AVE is computed only for the, which one? For the mode A. AVE will be calculated only for the reflective, never for the formative. Okay. So maybe you need to consult the slide of Dr. Sandeep once again. Last he gave. In case of reflective, 7 things to be reported. In case of formative, 5 things to be reported. In case of CCA, everything will be reported. Goodness of it, rest of the things are the same. But I am more interested in looking for the p-values. Where are my p-values? This is my p-value. Now look it. I said satisfaction is my formative. Sorry, boss, not allowed. What it means? This value 0.01 null hypothesis, this value is equal to 0. And look at the p-value. Can you see the sign? Change in the sign. So 0 will lie between them. It means null hypothesis accepted. This value is as good as 0. This value is okay, but this value again negative. This is 0. This is 0. It means it's not a significant construct. So in the formative, what should be there? All of these values should be. Why it's not doing? Because of it says these are four, not the separate thing. This is one and the same thing. So all are almost zero. Look at the sign change. When the lower is negative, upper is positive. Null hypothesis accepted. Whatever you are checking is as good as zero. So satisfaction 1 is not a good item for the formative item. Satisfaction 3 is not a good one. Satisfaction 4 is not a good one. Why not a good one? Because actually my data is reflective. I'm trying to, put it, make it as a formative, not allowed. Likewise, look at the loyalty. This one is 0, this one is 0, this one is 0. So looking at the p-value, we can get this. I hope you understand what Dr. Sandeep said. This is the value and this is the significance. These are two things. And one additional thing I tell you, whenever you say out of the 4 statements, 3 are actually out, this is only because of this satisfaction 2. He kicked out the others. It kicked out the others because of multicollinearity. This is remember, these are highly correlated. These are exactly same. So anyone will stay. So in the formative, totally they are different, no correlation. So everybody will stay. So if you try to make a formative, remember formative, we are happy with the multicollinearity. We call it with the name of alpha. But when it becomes a sort of regression that it's shown its colors, 3 are out, 1 is in. So that's the way. So shall we go for a complex model? I hope you are with me. And in case you missed out, the video of this workshop will be available. And this I have uploaded on the name of the playlist is PLS with RStudio. PLS with RStudio. I have defined all the files. Everything is available. Let's make a complex model. Okay. This one is the complex model, and let me remove it. So we don't know. Now tell me. Look it from the top and tell me where I will put the 1, etc. Total number of 1. Shall we calculate total number of 1? How many arrows are there? I can see 5 arrows. So at the maximum, there should be 5, 1, other all 0. Quality to quality, 0. Quality to satisfaction, 0. Quality to loyalty, 1. Behavioral intention, 1. Satisfaction to quality, 0, 0. Satisfaction to loyalty, yeah, there is 1. Satisfaction to behavioral intention, yes, there is a 1. From loyalty, there is only 1 to behavioral intention, rest all are 0. And behavioral intention, all are 0. Check the number of total are the 5 ones. Okay, so shall we run this? What are the changes we will make here? Let me remove this one, don't save, and open up. I have given it with the name of demo complex. That's not very complex, but I have given the name. So I will write 0, 0, 0, 0. So I have written quality C. C means in this order 0, 0, 0, 0, 0. Satisfaction 0, 0, 0. Correct. Loyalty 1, 1, 0, 0. Right. Behavioral intention 1, 1, 1, 0. Is that okay? So require it's already done. Demo is already attached. Quality, satisfaction, loyalty. This R-bind put all together. This is optional one. Inner plot. Let's check the diagram. Quality leads to behavioral intention to loyalty, satisfaction to behavioral this, loyalty to this. 1, 2, 3, 4, 5 arrows are there. Seems good. Okay. Let's come here. Now 10 to 15, 16, I have given the respective position. There are 4. So I have given, can you see there are the 3, 10 to 15, 1 construct. This is second construct, third construct, fourth construct. Let me make it, let me see if I can cheat it out mod. XX, it says, sorry, you have given the 4 construct here in the R bind, but here I can see only the 3. Only the 3. The length of the modes differ from the length of the blocks. You defined 4, but here you have given the 3. How come it knows 3? This is 1, comma, second, comma, third. Where is the 4th one? Okay, you can't make full. Okay, this is the 4th one. Okay, mode, it's a reflective or formative, and demo. X means my diagram. Out means my relative position. Mode means reflective formative. Scheme is path. Boot value T 500. Run. So it's taking a minute or so. Let me clean in the moment. If you want something to particular thing, we will see plot or the other details like show me the original data, show me the construct score, show me the goodness fit. Somebody will give you everything except a plot. So let's try to see this. It will take a minute or so. So any sort of complex model, remember those serial mediation, parallel mediation, this will be so fun to make. Just change, make slight change in this one, 0 and 1, and rest give the complete one. Let's see the output. Give a lot of space to it. Complete output is available. Total number is for latent variable, 100 observation, 21 this, standardized data working with, we are working with path, 10 to the power minus 6, 500, all 4 are reflective. Alpha seems good, D0 seems good, eigenvalue more than second, good. Unidimensionality arrived, convergent validity holds true. Model, since all of them are reflective, only look at the loading, seems good. See here we make some quicker mathematics. You know, we say AVE should be 0.5. What is AVE? Average of the R square. Take its under root. So average should be 0.71. If you do square of 0.7, it will be 49 and 71 will be 50. So we simply assume, look at the first decimal place. If everyone is 7 or more, AVE will be more than 0.5. Like what about this 1 is 6. Don't worry, 3 are 8 also, no? So average will be more than 0.7. So AVE will be good. Look here, there is a 0.6, but there is a 8 and 9 also, good. 7 is there, but others are 7, 8, 7, 9, it will be good. 6, 7, 7, 6. This 1, 6 will be, you know, compensated by 8, but there is a 1 more 6. It may create a problem. You need to check AVE. It will give. Cross-loading table, routine, inner plot, I think all are good. Behavioral intention, oh my God, satisfaction is not good. Satisfaction is out. For the loyalty, the 3 are good, but for the satisfaction leads to behavioral intention, no. P-value says deny, no, not allowed. Value is very, very less. Okay, these are the values. AVE, fortunately, it's good. More than 0.5 in all the 4 cases, good. R square it has given. R square will be given only for dependent variable. So no point in getting for quality satisfaction. Dependent are loyalty and behavioral intention. They are okay. Goodness of fit 5.1. These are direct and indirect relation. Look at the bootstrapping. I think weight we don't require. Loadings, all loadings are good because I'm just looking at the, is there any negative sign in this value? No, no negative sign. Good. Here, 2 values I see negative. 1, satisfaction leads to behavioral intention. This is negative. This is 0. Loyalty leads to behavioral intention. This is also 0. Oh my God, my model is flop show. Because out of my model, just see, satisfaction leads to loyalty. This is 0. And loyalty to behavioral intention, this is 0. So what will happen if this is not there? There cannot be any mediation. Remember, for the mediation, first there should be a direct relation, then indirect. When this is not 0, only 1, quality leads to behavioral intention, quality leads to loyalty. Though 2 are okay, rest all are 0, useless or flop shop. R square value, total effect, etc. all are given. Let me quickly show you. Can we make a good fit? Yeah, sure. Let's see that. So I have created my console on left hand side because I want to use this plot. I can clean the plot. This brush is used for cleaning up. Where is the plot? Plot XX arrow position this. Let's see what sort of diagram will come. This okay. And what I have written here, I have written what loading. So what to show? Loading should be shown, and arrow width is 0.5, like how much wider it should be. And you can set position also. This is set arrow POS. See, if I write ARR, it's a arrow position. Arrow position means where I should display this. If I'll say 0.5 exactly at the center, let me say not at the 0.5, rather 0.25 with the construct. Oh, not this, the previous one. Arrow position I have given 0.25. So is it okay? Quality leads to behavioral intention 0.4. This is 0.49. This one, this one, this one. All values are shown here. If you want to complete this along with its statement, there is something else. It's called what plot what. First one is XX. That's a simply inner model. Now I said plot outer model. XX what is equal to loading. Arrow width is 0.5. Arrow position is equal to 0.25. Let's run it. Oh, very complex diagram. Fortunately, we have a zoom. Zoom means this diagram comes like this. Oh, I have done 0.25, so it becomes a sort of a, you know, this I should do 0.5 or something, but these will be shown, all of them. I know they are not beautiful, but that's okay. If you do question mark plot, it will tell you all things. And these are if you want to see the model, original data, goodness of or original, only goodness of it, 0.52. Only in the model, outlier model, you just click on them. This will come. And if you understand them, then you will just take maximum 5 minutes to understand the CCA. That's what I say. You know, you just learn RStudio once. Then once you learn it, it's something like if you know how to fly a plane, then I will give you different models of the plane and you will fly every plane. Don't worry. Let's come to CCA. So what difference we should expect in the CCA? Only in the model specification. So I'm working here with the data satisfaction. This Dr. Sandeep shown you this model. Oh, sorry. Dr. Sandeep talked about this model. This model says, now when I put a benzene ring, a hexagonal structure, it means it's a composite. Number one, where from composite will come? It will come from the theory. You need to write that this is a composite, why it is a composite, why there are only finite sets, etc. You need to define it. First thing and the most important thing is review. Review, writing, convincing the editor. Don't take or don't tell. Neeraj told us that quality has to be this. No such thing. Write your relevant review. I am just telling, if you have a composite, how part I am explaining, how to do it. Dr. Sandeep explained why part in great detail. So I am just explaining how part, how to do it. So this is construct. These are composite. 4 are the composite and 2 are the reflective. Remember, reflective means equal to tilde and composite means less than tilde. This is it. This is it what you require. So this particular file is given in the CSAM package. Require CSAM. Done. So let me take my console on the left side. We don't require this. Now see, data satisfaction. Now satisfaction is the part of this package. How do we know? Let's check it. Go to the package. In that package, let's go to the CSAM. Is there any package CSAM? Yes, CSAM is there. In the CSAM, what are the things? It says I have this data enemy, I have this SS model, this is a function, calculate CVI, calculate this, these are all the functions, okay? Or I tell you when the simple method is. The simple method is, you simply write here as data, and it tells these are the all the data sets available. You know, this is so good. Simply write a data. It says in the CSAM package, there is a data about this. There's a this IT flex. There's a Lancelot mill something, political democracy, reset, switching, these much data sets. So I have a satisfaction. 2 data sets are there. Satisfaction only and satisfaction including the gender, which will be used for the multi-group analysis, etc. So there is one important point here. I told you there are the first 3 points in RStudio is IVA, import, view, attach. But when you take a data set of a package file, then import is not there. Import means it is not in the R, you are importing from somewhere. That's why it can be CSV file, it can be SPSS file, Excel file, text file. But when it is part of any of the package, simply write I will be lost, other 2 will be there, attach and view will be there, but simply write like data satisfaction, done. View satisfaction, so this is that file, image, then from the image expectancy and other so many, all these things are there. Okay, so it says 16 are the column, 250 are the rows. Okay, that's fine, thank you. Demo not required. And now let me come to the environment, and shall I clean it? Clean all, everything gone. Yeah, we can start from the clean slate. So require, it's done. Data satisfaction, it's done. View, we have done. We can check it once again. Yeah, it's there. Now look for the model. Model, now either you can write this one less than or equal to. Both are the one and the same thing. Almost everywhere in all the books, maybe in all of the video, everywhere people use this symbol. I personally feel equal to. I feel more happy with equal to symbol. Okay, you can work with any of the symbol, both works. Now, double quotes. I'm explaining not in single apostrophe, I'm explaining in double quotes. So this hash means don't read. Okay, satisfaction equal to tilde. It means it's a reflective, and image I have given less than tilde. Do you understand? This is a reflective and this becomes a composite. That was it. That was the only difference. One more difference. The package is CSAM. For reflective, the package was Lavan. It means CSAM will take care of Lavan also, because it is we are not required Lavan, because it already says I will work on Lavan also. I know what Lavan will do. I will do that stuff also. What it means, expectancy related to this is the structural model. Let's see the structural model. Expectancy is related with, now it's a check it, it's a single-sided arrow, not the two-sided arrow. So we will use a tilde. Tilde means how to write it. Image has an effect on expectancy. Image has an effect, read from right to left. Expectancy has effect on quality. Quality, correct. Value, see there are two incoming arrow. Value has an effect from expectancy and quality perhaps. So value, expectancy and quality. Satisfaction got 4, image, expectancy, quality, value. So satisfaction got 4 of the thing. Simple plus. Loyalty got the 2, so make the 2. This is the similar to the CFA, different from Professor Gaston Sanchez, which is said. So shall we run? Run, done. Okay. Now my model is prepared. My data file is satisfaction available. Write only the two things. CSAM dot data. Now this is a way you need to write. Dot data is equal to satisfaction. Dot model is equal to model. Model means, see the name. I have given it as model. Earlier I was calling it as X or out or something. Now I'm calling it as model. Only 2 steps. And run. And now I will get entire output is available in the result. Now we will take it one by one. CCA is complete. Only thing is, let's take out the output and read it. See, it's so simple. Just in the 3 lines. 1, require. Second, that's okay. Data, which data, etc. Define the model and run. CSAM is equal to this. Output is in the result. Now I will take one by one out. First thing is, if you want to get the construct score, you want all of these should be computed and give it score so that I can manually check or something. So there is, see, in the result, if I'll say dollar, it means it says got so many things. Okay. In the estimate dollar, it says still got so many things. In that, I want from here, let's see, construct score. So that's why I have written it like this, that result dollar, from the result take out the estimates, from the estimate take out the construct score and show me the scores. So shall I do it little this? So these are the value of all of the scores available. You can export it directly to your CSV file, Excel file. That's not an issue. That's absolutely no problem. All, I think all are there. So look for image, expectancy, quality. The next comes as the value, and 2 are here. And how much value? 166 they are given. There is an alternative method also. No, we are not, that's okay, we can do. But show me the result. Now comes the magic. I just love it. See, verify. Now verify is such a wonderful thing. It says, do you remember those sort of a very complex thing like convergence achieved? Yeah, okay. All absolute value loading less than, remember it's a Haywood case. So many people ask for that, what's the less than, why beta is greater than 1. When there is a discrepancy in the data, then it becomes this Haywood case. So this will automatically check first the 5 things, whether things are admissible or not. So good news, it's admissible. All construct a positive semi-definite. Remember this, in MOS you get non-positive definite error is there, negative value comes, that is okay. Or liability less than 1, yeah, okay. Model fit implication positive definite, yes, okay. Model is admissible. See, this is part of sort of machine learning. So it gives you in line written, this is done, need not to worry. Professor Hensler, hats off to you. Just a wonderful thing. Look for the, okay, we have done it. What we have done? Verify. So let me show you their way of working. So what is it? It's called, okay, I have explained it in this. Let me show you here itself. These are the models, reflective and composite. This is the structural part. This is the R code we will work. Basically, the Professor Hensler says Let's see. He says there is a model, there is a data. Run with the help of CSAM data and the model. You will get the results. Now these results you put it into the various things. What you can see: use access, use infer, use predict, summarize, verify. Likewise, put these results into test of model fitness, multi-group analysis, MICOM, Hausman's endogeneity test, IPMA, surface modeling, redundancy, floodlight. My goodness. Anything that you do in the smart PLS, etc., this will do all of them. Plus, it will work on the CC also. It will work on those reflective, formative, this, it will work on everything. So it becomes the CSAM. How will you do? Basically define the model, take a data. First step is get this, get the result of this. And that result you will put in one by one. Now, this is in development state. Floodlight analysis, till date, it's not activated. They will say we need more time. Redundancy analysis, remember what is redundancy analysis? Dr. Sandeep told you, for the formative construct, convergent validity is assessed by redundancy analysis. You know, it may seem like I'm talking all, German or Greek words, but the slow by slow, you will understand there is a redundancy analysis. Formative construct, convergent validity is assessed by redundancy analysis. Surface analysis, I have no idea. It's not activated. IPMA, perhaps it's not activated. Test, yeah, it's activated. Multi-group activated, all. Hausman not activated as of now. So this is the way. So they say our result is basically, we will go for verify admissibility, measurement model, all sort of, remember, measurement model means AVE, CR, rho, etc. all those. Bootstrapping means whether there is a significant relation or not. Model testing, all, I require all, GFI, CFI, NFI, all I require. Higher statistics of Hausman, endogeneity test, IPMA, floodlighting, etc. These are the, so just run one and then you go ahead with it. In the verify, 5 things it will check for you. What are the 5 things? Convergence achieved or not. All absolute standardized Haywood cases it will check. Not positive definite it will check. All reliability less than 1 it will check, and the model also VCV it will check. The 5 things. In the access, we'll say show me the all measurement. It is called access, and put that output here. It will give you AVE, adjusted R square, internal consistency, all sort of alpha, not only Cronbach, others also. Discriminant validity, not only MSV, STMT, others also. Model fit indicator, all model fit. Effect size also it will give. It will give you VIF also. Bootstrapping, it will give you path coefficient, factor weight, factor loading, total effect, indirect. Bootstrapping it will do for all of them. Model fit, test of overall model fitness. So it will check for the same which smart PLS checks, DG, SMR, DL, etc. And plus this is overall model check, and then it will go for individual checking, CFI, GFI, NFI, those things. Higher statistics, it will go for MGA, multi-group analysis, MICOM or MGA, IPMA, redundancy, predict. This is the same predict which you can do with the help of PLS, the same predict. Non-linearity also, Ramsey test, endogeneity, it will also check this. So reporting, now there is a paper by Professor here, and if you have read about Professor here, the remarkable thing, every single thing he put in so systematic manner. This from the Journal of Business Research. I think it's available on ResearchGate. So he says, this is what you are asking Dr. Sandeep again and again. He also highlighted the same thing. Reflective, loading and significance. You understood it? Loading means which beta value which constitutes AVE. Significance means they check for the bootstrapping, they should p value should be less than 0.05. Indicator reliability, Cronbach alpha. Composite reliability, CR. What is the difference? In indicator reliability, in Cronbach alpha, only statements are taken and their correlation, from there we compute alpha. Composite reliability also take care of the error. Explained divided by explained by plus total error terms, not explained. It takes, that is called CR, composite reliability. AVE, discriminant validity, nomological validity, and predictive validity. These are the 7 things we should report as per Professor here. For reflective, for formative, convergent redundancy analysis, multicollinearity, VIF value, size and significance. This I told you, size means 0.2, 0.3, and significance p value less than. Contribution, size and of the loading, etc. predictive. This I'm not sure. Loading we don't see. We'll check what Professor here was saying. And predictive validity. In CCA, structural part, we define structural model, collinearity, R square. There is something called in-sample prediction, F square, R. If you know about this, the team of Professor Ingle and others, they focus a lot on the predictive part. They say there is no point in going for the post-diction. You must go for the prediction. So they say there is something called in-sample, that is R square. But there is something, a better version is effect size. But still, both are in-sample. You take something else, there is called predictive relevance Q square and PLS predict. These are the many things for the future prediction they say about. So now we can go back. I think we still have the 5 minutes. So where we were on R. Verify the results. We have done the verification, right? Now test of model fitness. Now my friend Dr. Nisha told me that most of the time these various statistics in R, every time they produce a different result, because remember they work on the bootstrapping. Bootstrapping is a random sample. So it might be that my results are something different and your results are something different. So what we need to do, we provide that one instance. For example, I have written set.seed 1, 2, 3, 4, 5. If you also write the same, so it means for the bootstrapping, we will take a particular way of sample and our results will be exactly same. So you should always start with the set seed for some. If you don't do it, what will happen? If you do, it will say random seed not found. Okay, so there is simply any number you can write set seed. Okay, now test of the model fitness. It will take a minute or so, and it will tell me whether my things are admissible or not. Okay, don't expect it. Generally doesn't come good. It will give me the critical value. If my calculated value is less than critical value, my things are basically I'm looking how much good model fit I have done. So generally it says not a good fit of the model. It is working on the bootstrapping, taking so many subsamples, hundreds or the maybe 5,000, whatever number I have given, so much samples it has taken. And it says, sorry boss, flop show. Why so? See, this is a wonderful thing. In the new packages, see, it's written like this: null hypothesis, modeling, this test statistics. My test statistics for DG comes 0.6. Critical value is it should have been 0.3. My value is more than this. Null hypothesis rejected. Not enough. SRMR, standardized RMR 0.09. It should have been 0.05 with my given data set. Actual value should be 95. This rejected. So it means not very good. It's not able to. What will say, model fitness is not good, but it's still admissible. Remember, it was admissible. Model fitness is not good. Okay, don't worry about that. Let's see something else. Then we have assess the result. Now it will say, okay, let me show all without p-value, structural part. Oh, see, you are given a lot of results. Remember, satisfaction, loyalty, these are reflective. So their AV will be computed, not of the composites. R will be calculated for all dependent variable adjusted. Now this is internal consistency, Cronbach alpha, Jocus Rogs rho, Dijkstra, Hensler's rho. 3 they have given because Hensler and team has made that. Internal consistency, rho C underscore MM, rho weighted. My God, read about them. RHOT, rho weighted, MM, rho weighted. So many. These are not available in other softwares. They have given it. These are those CFI value 0.85. Okay, it should have been 0.9. GFI 0.72 less. IFI 0.6 slightly low. It should have been 0.9 for the good model. NFI, RFI, RMSC, all models are given. VIF value. VI value when for VAL, look at my model. VAF. Just let me go to my model quickly. This was the model. Where is VAL? Yeah, VAL got the 2 incoming arrow. In the 2 incoming arrow, 3 something. Okay. If it is VIF value less than 3, absolutely no problem. Up to 5, little bit. More than 5, certainly there is a problem. Up to 3, like 3.2, okay, it might be both are okay. Both you may find it significant. For satisfaction, there are the 4 quality poses some threat. Otherwise, it seems okay. For LO, while all are seems okay. Effect size. What is the value of effect size? 15, 35 and high. Up to 15 low, 15 to 35, some books say 30 is moderate, and more than that is high effect size. Effect size is calculated for all DV. So see, experience is DV. Only for the DV effect size is calculated, F square. Validity assessment, STMT, okay. STMT will be calculated only for the reflective, remember, not for the composites, for the lacquer criteria also. Effects, p-value is not computed because this is only for the effect. ASS, ESS, SS is only for the reflective ones. VAF, etc., various accounted for. This is the part of looking for mediation. Leave it. Anything else you have? Yeah, bootstrapping I have. So for the bootstrapping, you need to write like this: CSAM data satisfaction model resample is equal to bootstrap. If you do, it will go with the bootstrapping also. I'm saving it in the result 1 so that previous results are not overlapped. So let me run it. It is taking a little time. Then I will run it and I will see the same values, but along with the what? Along with the p values also. So p values will tell me whether there is a significant relation or not. I have taken only 3 of the argument. You could specify how many samples should be there. So that what you need to do, question mark CSAM, it will give you all sort of the argument what can be done. Like you can say, give me only up to 500 samples, 5,000 sample of the bootstrapping. Other methods, other than bootstrapping, there are other methods also. I think one method is, shall I check it here? Oh, it's a CSAM. I think it's the jackknife. It's something concerning Dr. Nisha and Dr. Sandeep should listen to this. Jackknife is other method, which is actually better method. Resampling method, yes, jackknife is more preferred as compared to bootstrapping method. People have not understood bootstrapping. Jackknife has said that there are problem with the bootstrapping. Jackknife is suggested. It's a better method as compared to other. Okay, so show me the results of this summarize. So let me give a lot of space. Run. Wow. So much output. So this is the same. This is the bootstrapping. These are the random seed. It has taken this much random seed. Mode A and B, you understand? Mode B is composite. A means it's a common factor. This is it. Composite or common factor means it's a reflective. Now you got the T values also. Again, the rule is the same. P value greater than 0.05, null hypothesis accepted, or look at the sign. If there is a change in the sign, negative to positive, null accepted, this value is as good as 0, no relation. And likewise read it. Loadings, the same result. Now it got along with the loadings also. Indicator correlation, everybody is correlation. Image 1, image 2, image 2, 3, 1, 3, that everything. Estimated total effect, indirect effect, all. Now this is part of the mediation, indirect effect and the total effect. From there we find out the things. 95 limits, predict. If you want this any particular thing. So this is CFI, this is GFI, this is IFI. If you want that, otherwise earlier we had all. Reliability if you want to calculate, otherwise in the summary we had all. If you want to calculate, these are the part of